Hey y'all, I'm on page 132. We're going to do another practice problem on solute potential. So in order to save some time on this video, I did some calculations ahead of time. Now, just as a reminder on how to calculate the percent change, all you're going to do is subtract the initial from the final, so final minus initial, divide that by the initial mass, and then multiply all of that by 100. That will calculate the percent change. So in my table, I have the percent change in the molarity, which is what we're going to graph down here. And again, in order to save some time, I went ahead and made my scale and my labels. I forgot to actually label this, so I'll do it real quick. There we go. Done. Easy. So at 0, this is going to be where we would have an isotonic solution. We'd have no net change. Anything above that, my positive net change, is going to be because the solution that it is in is hypotonic. Anything below 0, where we have a negative change in percent, a negative percent change in mass, is going to be because whatever it is in a hypertonic solution. So we're going to graph these. At 0 molarity, we had a 35.9% change in mass. So I'm going to graph that at 0. Should be about here-ish. Okay, at 0.1 molarity, I have 23.6. So I'm going to graph that about here-ish. At 0.3 molarity, I have 10.9 positive, so I'll graph that about here. At 0.5, I have a positive 9.4, so that would be somewhere about here. At 0.7, I have a 6.2. Somewhere around here. At 0.9, I have a negative 9.9, somewhere like that. And at 1 molarity, I have negative 11.7, so somewhere around here. All right, so the next thing you're going to do is draw a best fit line. Okay, now since the line hasn't been drawn for you and you're drawing it on your own, there is a little bit of wiggle room as far as what would be acceptable. Okay, we know for sure that it's got to be above 0.7 because anything below that is a positive change in mass. And we know it's got to be somewhere below 0.9 because anything above that is a negative change in mass. So I'm going to draw my best fit line somewhere that's going to cross essentially where these dots would be going if I could only fit one line. So I'm going to say, I'm going to take a straight edge too. I'm going to say it'd be somewhere like this-ish. Okay, your line might be a little different than mine, but this is about where my best fit line was drawn. Okay, the reason it's important that you know that there's wiggle room is that you definitely need to mark where your line crosses and what number you're using. That way, whenever you plug in this concentration into your formula for the water potential, or solute potential, which is the water potential in this case, the AP grader or Ms. Lopez or I know exactly what you're doing, and we can actually see that you've done your calculations correctly. So mine is probably around, looks like mine's actually probably right around 0.8 molarity. So make sure that you label that on your graph. Okay, again, we want to make sure that the person grading your paper knows that you know what you're talking about and you know what that C represents, which is where there would be a 0% change in mass. So the next thing we're going to do is we are going to plug this number into our formula. Okay, so for water potential, the water potential equals the pressure potential and the solute potential added together. In this case though, the water potential is equal to the solute potential because it's an open container. So we're going to go straight down here to the solute potential equation, which is negative I CRT. Gives you all of these numbers down here. We just have to plug them in. Okay, so the ionization constant for this one is 1 because we're talking about sucrose. So my water potential, which equals my solute potential because I'll focus that. Because it's in an open container, is negative I CRT. Okay, that negative I is 1. The C is my concentration, which we found to be 0.8, the way that I drew my line. Your line might be a little bit different, but as long as you've marked it, we can check your calculations and know that you've done it correctly. My R, according to my chart, is 0.0831. And the temperature is the degrees Celsius plus 273. The degrees Celsius in this problem is 26.8. So I'm going to plug that in. 26.8 plus 273. And I'm going to plug all that into my calculator. So I have, let me turn it on, negative 1 times 0.8 times 0.0831 times 26.8 plus 273, and that's going to give me negative 19.93. And that's it.